Good afternoon, everyone. Can I ask you now to take your seats? I'll just wait for a few last people coming in. It is my honour and great pleasure to introduce our gold medalist today. Valerie Masson-Delmotte completed her engineering degree and master's at the École Centrale de Paris in energetics and physics of fluids. Her PhD from the same institution on past climate modelling started her on her career-long passion. She is currently a senior scientist at the University of Paris-Saclay. Over her career to date, she has supervised 22 PhD students and 5 postdoctoral early career scientists. Valerie's professional activity has 3 main dimensions related to advances in climate sciences: basic scientific research, climate change expertise to inform climate action, and climate outreach to strengthen climate literacy. She is a prolific and highly cited author of peer-reviewed papers on these topics. She was co-chair Working Group 1 of the IPCC 6th assessment cycle, which was from 2015 to 2023, through which she has co-supervised several IPCC 6th assessment reports, having previously been an IPCC lead author in 2007 and coordinating lead author in 2013. She has provided scientific advice to numerous organisations over many years. Some of her outreach activities has been, as part of her IPC co-chair role, to disseminate outreach products, making state-of-the-art climate science outcomes more broadly accessible, but she has also written several books for children and for the general public, enhanced climate literacy through training sessions with journalists, teachers, government and government advisors, and city decision makers, amongst others, and communicated climate science through social media, for example, with 26 million Twitter views in 2022. Valerie has received many honours, including honorary degrees from the Universities of Utrecht, KU Leuven, Bern, and from the Tibetan Plateau Research Institute in Beijing, the Descartes Prize from the European Commission, the Martha T. Muse for Antarctic Science, CNRS Silver Medal, EGU Milankovitch Medal, SCAR President's Medal, and now our Gold Medal. Valerie, I invite you to give your Gold Medal lecture.
Thank you very much for the medal. Thank you very much for giving me this medal in Berlin. It is in Berlin, as a first-year PhD student, where I could attend my first international meeting. And it's particularly important for me to get it from IUGG, as the atmospheric scientific community and the cryospheric scientific community have been extremely important for my own research and for being part of stimulating international networks. I also would like to say hello to many colleagues and friends, many of whom I have not seen for years. It's also a pleasure to see here many of those who have contributed to the IPCC reports over the last 8 years. So this presentation is on the physical science basis of climate change, empowering transformations. And some of the outcomes of climate science are illustrated here. Global warming over the last decade now reaching 1.15 degrees above 1850-1900, and human influence being unequivocal. Future climate depends on future emissions. We have choices. The intermediate scenario reflects closest to the implications of current implemented policies, but with larger immediate emission reductions, we could limit warming within around 20 years. It shows the importance of providing accurate climate information to empower multiple transformations, actionable regional information to inform risk management and adaptation strategies, in particular in the most vulnerable contexts. Training new generations of scientists everywhere. informing adaptation limits and geophysical constraints for mitigation strategies. This cycle has been a marathon. None of us, when we were elected in September 2015 as members of the IPCC Bureau, expected, in the context of a strong effort on sustainability, the Sustainable Development Goals, the Sendai Framework on risk management, the Paris Agreement, none of us expected to receive 31 proposals of special reports. We did our best to cluster them, and the IPCC government panel decided that we would prepare 3 special reports, and the physical science basis is present in each of them. The numbers provided here give you a sense of the efforts to deliver the 1.5 degrees special report, which showed very clearly how much every increment of warming matters, the scale of the challenge if we would have been to limit warming to that level, and the importance of strongly embedding climate action into the multiple dimensions of sustainability where every choice matters. The Ocean and Cryosphere report showed how much we depend on the state of the ocean and the cryosphere, the committed responses and irreversible changes, and the importance of building resilience, which I call running against the clock. The Climate Change and Land report was the first one to address the food system in a systemic way, showing response options that can address multiple challenges, not just adaptation, mitigation, land degradation and desertification, but also biodiversity and food security. It's touching core human security issues. It is the one least reflected in actual effective climate policies worldwide. We did our best to enhance climate literacy, building on those reports, an infographics showing a story of 3 possible warmer worlds. And if you read these storylines that were developed by the authors, they strongly resonate with what has been observed since 2018. International tensions, dramatic effects of extreme events, and slow advances in effective climate actions. We worked also with the Office for Climate Education to develop resources for teachers so that the best available science is not just used to inform decision makers and at the international level, but it can be used in the classroom and be transferred as fast as possible to today's children who will be the decision makers of tomorrow and will live in a warming world. And in parallel with the 3 special reports, we started preparing the main Working Group 1 Physical Science Basis report. A lot of work in parallel. The chance was that by working across the usual working groups, physical science basis, impacts, vulnerability and adaptation, mitigation, we started early on to think of integration, of which part of climate science is relevant for the handshake in terms of needs for risk management and adaptation, and the handshake in terms of geophysical constraints on mitigation and climate and air quality co-benefits or trade-offs. I would like to give you a sense of the human adventure behind IPCC reports. You can see here the 234 authors and 30 chapter scientists at our 3rd lead author meeting in southwest France before the start of the pandemic. When we assembled the author team for the Working Group 1 report, we wanted to embark a new generation of scientists, 2/3 of them not previously involved, median year for the PhD degrees, 2002. And I have to pay huge tribute for everyone involved, including my fellow Working Group 1 Bureau members, my fellow co-chair, Padma Ojai, on the center of the photograph here, the coordinating lead authors. You know, we said before, being an author of IPCC requires to be available about 30% of the time to be a lead author, maybe 50% to be a coordinating lead author. But over time, and especially because of the pandemic, it was much more than that. And thank you so much for staying on board and putting all your efforts to consolidate a robust and rigorous assessment. It would not have been possible without the support of our technical support unit led by Anna Pirani, who was amazing in terms of supporting innovative approaches, and I'm going to describe some of them. In fact, we had to overcome a number of challenges. We select authors, 1,000 volunteers, based on their expertise. We pick up what we think would be the best minds and skills to develop a new report. But then we face unconscious biases and tensions, sexist behaviors, scientists with different cultures, different accents in English, not being heard when expressing bright ideas by the group. How to overcome such challenges? And we took advice from specialists of inclusive and participatory approaches to provide guidance, training, and support so that when the expertise is there, it has a voice and it shapes the reports. We also struggled with delays in the availability of climate modeling results. In fact, the delays due to the pandemic allowed some of the studies to be available on time to support the updated assessment. And we were struggling, all of us, due to a warming world, a heat wave during a lead author meeting without any air conditioning. We also struggled with some authors trying to participate while their cities was flooded during heavy rainfall and tropical cyclone events, or some of them having to evacuate their universities because of wildfires in many countries. When the pandemic arrived, we were at the stage of the second or the draft review of our report. It was well advanced. The dynamics was there. And I really thought it was impossible to stop that process, otherwise we would not be able to deliver a report. We adjusted everything with lots of deliberations, surveys to editors of scientific journals, surveys to the authors of the report. And by a few weeks' delay, we managed to secure an effective, in-depth review process and the delivery of a timely report. We built on new approaches to facilitate inclusive virtual meetings. We continued to build on collective intelligence, which is the strength of the IPCC process. We struggled with the stress level, and some of the authors had to face burnout situations, which show how unsustainable the process is due to the increase, in particular, in amount of peer review publications to assess by a small team of authors. We designed and ran the first ever virtual approval process, 186 hours on Zoom over 2 weeks, and at the end, a strong and impactful summary for decision makers. Behind that process, there was the intent to change the structure and the outcomes of the physical science basis report. As I indicated before, there's an ever-ending increase in the number of publications with the keyword climate change. This increases the burden. At the same time, there are efforts for regional assessment reports, topical assessment reports, and in particular, what the World Climate Research Programme has supported to deliver an updated assessment of climate sensitivity, building on multiple lines of evidence, paleoclimate, observations, process understanding, emergent constraint, has played a key role in advancing the assessed state of knowledge prior and in parallel with the IPCC process. The goal was to shift from a structure which was traditional, observations, model evaluation, an approach component by component. This was done in this way for the 4th and 5th assessment report. We knew how it was feasible, effective, comfortable for scientists because you operate with your own community within a given chapter. But this is not what is expected from decision makers. They expect a more integrated approach. So we developed a structure in 3 main pillars. The first one is large-scale information. What is the state of the global climate system building on key indicators compared to paleoclimate evidence? what is human influence today, and what are possible near-term, long-term, very long-term futures, depending on scenarios and modeled constrained responses. Then we have a core part, which is reflecting the advances in process understanding. Of course, the global carbon and biogeochemical cycles, with relevance for the handshake between the physical science basis and mitigation, in particular through the remaining carbon budgets. An emphasis on short-lived climate forces due to the strong importance of better coordinating climate mitigation and air quality control policies to build on co-benefits and avoid trade-offs. The advances in the understanding of the Earth's energy budgets, which include feedbacks, in particular training simplified climate models, emulators, with the assessed climate sensitivity that have been used to classify hundreds of socioeconomic pathways by our colleagues from Working Group 3. There's a strong emphasis with a new chapter on water cycle changes, which is a handshake with the water cycle of the Working Group 2 report, focused, of course, on water management and adaptation responses. And an update of the special report on the ocean and cryosphere report, with a focus on altogether ocean, cryosphere and sea level change. And about a third of the report, and that's really a strong development, is focused on regional information, with the assessment of methods linking global to regional climate, with the importance of relating regional characteristics to a global warming level, and providing actionable regional information to inform risk management and adaptation strategies. In that direction, we framed 33 climatic impact drivers, which are physical conditions known to drive impacts, and provided a strong handshake with the other working group on risks within the risk framework by this explicit assessment. We also explored low likelihood, high impact outcomes and with storylines, narratives of physical changes which help to address possibilities that cannot be ruled out, that would have major societal implications, and for some of them are associated with deep uncertainty. We developed an interactive atlas as an open resource that can be used for education, training, outreach, and which is not a climate service, but gives a sense of what are advances in robust data sets and regionally relevant information. You may pay due attention to our glossaries. We worked hard in an interdisciplinary context to ensure that we define explicitly every single term that is used within and across these different disciplines. Altogether, this work reflects an enhanced integration across different research areas, different IPCC working groups, and when you look at the outcome, the synthesis report, it builds on evidence from 85,000 publications. It's the work of more than 1,000 lead authors with thousands of contributors and reviewers, and it has benefited from 300,000 review comments. For authors involved in the process, it's both a strength, it really shapes the robustness of the reports, but when they are received, it's a nightmare, to be honest. And I would like to thank networks of early career scientists who brought together more than 120 early career scientists who provided 2,000 review comments to the Physical Science Basis report. Some of these comments were of the highest quality, and some of the authors were so surprised they thought it was coming from one single person, the one who had, assembled the various comments and provided them. And it shows, I think, the added value of not doing review processes as an individual, but coordinated within a group, every person picking up 10 lines, half a page, 1 page of the reports, to double-check everything and to ensure that every aspect of the assessment is as rigorous as possible. And I think it's an excellent entry point to the IPCC reports. There are lots of early career scientists here today, My suggestion for reading the reports is to start by the final section of each chapter, which is, for many of them, focused on knowledge gaps. These knowledge gaps are part of the assessment, and they also show very strikingly what are the knowledge needs that are particularly critical to better inform decision-making in the coming years. We've run a number of expert meetings and workshops. I would like to highlight 3 of them. The Cities IPCC meeting in 2018 developed a research and action agenda on cities and climate change science. And the purpose was to stimulate the production of new knowledge, timely to inform the next special report of the IPCC prepared this year onwards that will be focused on cities and climate change. An opportunity to reach out to new practitioners, communities, local decision makers. The second one was a joint IPBES, IPCC workshop addressing biodiversity and climate change. And as you know, with the Montreal-Kunming Protocol, the need for information to support consistent climate and biodiversity policies is growing. And finally, with UNESCO and ICOMOS, we had a workshop on culture, heritage, and climate change, which could be really interesting for those like me who particularly like past climates, on how to reach out to the communities involved in heritage so that they can also empower transformations and climate action. We did a lot of efforts to empower outreach activities. The first one is the implementation of the FAIR data principles, with data and code available for many of the figures of the reports. We run user surveys, especially with science communicators, to better design frequently asked questions so that they would be relevant for actionable outreach activities. We developed 2-page fact sheets, 1 per region, 1 per sector, so that in a quick look, you can have access to a summary of the state of knowledge, and by clicking on the figures, you directly have access to our interactive atlas for the relevant information sources. NASA has implemented an atlas for the sea level projections, grounded in the assessment of our report, and available for the sites of every tide gauge data with long records. If you're interested in building from our experience, we started from the recommendations of an IPCC expert meeting on communication. We developed with a company in the UK called Climate Outreach a handbook for IPCC authors. It's valuable for any scientist, in fact. And we also took lessons learned with them on case studies from IPCC authors who have engaged with different communities, different sectors in multiple ways. And they can be inspiring on how to use your voice as scientists to promote transformations around you. For the first time, we developed a plain language summary, the summary for all, and even using cat cartoons. Thanks to good-willing authors and scientists, this one is translated in more than the 6 UN languages, with the possibility to make this state of knowledge more broadly available around the world. Thinking of climate science, I found it frustrating that we had no expert from the private sector involved in our assessment. I thought that typically in the insurance or reinsurance sectors, they might have been volunteers. Actually, their time availability is constrained by their employers. So after the report was finished, we partnered with the International Association of Actuaries to develop with them a product which is a summary for actuaries grounded in the physical science basis. We also developed a summary for urban policymakers with organizations of cities around the world, translating all the IPCC reports into plain language information that can be actionable at the city scale. So you see all these efforts to not just put light on knowledge advances, making information available, but also show that climate science is part of solutions, so that with new knowledge, you can be better prepared, you can better inform mitigation strategies. But how was that perceived? a few cartoons from different media around the world give you a sense of how IPCC is perceived, framing the urgency, framing the seriousness, sometimes the doom. But few of the cartoonists have picked up how you can use IPCC reports in terms of choosing your own adventure, using your agency, which is an important component, seriousness, urgency, and agency reflected in the AR6 assessment reports, which also show the options for action in terms of effective adaptation, in terms of the scale of mitigation options which are available now and, if implemented, could reduce global greenhouse gas emissions by a factor of 2 by 2030. And I would like to argue that advances in the physical science basis are critical to continue to support well-informed responses. So in the next part of this presentation, I will go across a couple of the key messages that were developed in a bottom-up process by the authors of the report, the scientists, supported by communications specialists, and which were impactful worldwide in how the reports were reflected. Of course, the first aspect is that recent changes in the climate are widespread, rapid, unprecedented for some of them in thousands of years or more, and intensifying. And you can see the display of recent warming in the context of the updated reconstructions for the past 2,000 years. There's a need to advance the use of past climate reconstructions for different variables on longer time scales at higher resolutions, to continue to be able to place current changes in the long-term context, but also to better understand the full spectrum of natural climate variability and how it can overlap with human-induced trends to drive unprecedented hazards. We show that human influence on climate is unequivocal, and this builds on multiple advances, including the closure of the Earth's energy and also sea level budgets, reduced uncertainty on climate sensitivity, so that we could combine two methods: the usual attribution method, simulating climate change with and without human influence and with single components of influence, together with studies of radiative forcing and climate response, and both give very converging results. It allows to show that the primary driver of warming to date are cumulative CO2 emissions, and when accounting for the effects of methane on air quality and ozone formation, emissions of methane are the second driver of warming to date. IPCC reports are released with multiple year time steps. So following the release of the 2021 report, 50 authors have developed indicators of global climate change with the same methodologies and data sets, with the aim to be able to provide annual updates. This is what is shown here on this side of the panel. And you can see the most recent update showing global greenhouse gas emissions increasing more slowly in the last decade, the effect of the pandemic and the small rebound, with a tendency to have a stagnation of fossil fuel emissions. You can see the continuous increase of greenhouse gas concentrations in the atmosphere, and you can see an updated assessment of human-caused global warming, now reaching about 1.14 degrees Celsius for 1.15 observed. And we confirm the fact that observed warming being driven by human activities in the last decade has continued due to increased warming effects from greenhouse gases and a reduced net cooling effect from air pollution control outcomes on atmospheric aerosols. Why do I put an emphasis on intensifying? When you look at what has changed between 2021 and 2023, you can see that all the signs go in the wrong direction. Emissions, concentrations, Effective radiative forcing has increased at a fastest pace in the last decade compared to the previous one. It's also the case for the Earth's energy imbalance, with a question mark whether it's accelerating or not. It is clearly demonstrated for sea level rise, not yet for the Earth's energy imbalance, and continued increase in global mean surface temperature, with human-caused warming occurring at the fastest pace ever in the latest decade. We also confirm that hot extremes with land maximum temperature are increasing faster than the global average. Human influence on the climate system affects extreme events, including heat waves, heavy rainfall and droughts, making them more frequent, more severe, and they drive impacts in all sectors: water availability, food production, human health, in particular associated with heat waves, trauma from displacement. They drive multiple changes and degradation in all ecosystems. Half of the studied species over land and in the ocean are moving, with mass mortality of trees or ocean species as well, and a loss of the fish catch potential in the tropics. Trends, extremes, climate change is affecting every region on Earth in multiple ways. We increasingly understand how these multiple climate conditions are attributed to human influence, and not just single extremes, but also compound extremes such as fire weather or compound flooding, driven by both sea level rise and more intense rainfall events over land that pose specific coastal cities adaptation challenges. We need more work to inform limits to adaptation, to inform the conversation on the loss and damage. And when you look at this visual, for instance, for heavy rainfall events, which intensify first because a warmer atmosphere can hold more moisture, but also because of dynamical changes, you can see that in grey areas there is a lack of available information. Sometimes high-resolution data exist but are not available, and there's a lack of attribution studies. In some of the regions which are hotspot of a changing climate, where 3.5 billion people live in highly vulnerable contexts. Considerations of ethics, vulnerabilities, should also guide knowledge developments, so that we do not only produce knowledge where we live, but we produce knowledge that can help inform responses in the most vulnerable contexts. We need to advance the understanding of climatic impact drivers that affect ecosystems. This was done in a quite weak way. In the AR6 Working Group 1 report, we focused a bit on climate velocity, some of the extremes. They are not completely integrated in ecosystem impact models, and there's a potential for advancing that knowledge in the coming years. When we look at scenarios and projections, the best estimate of future warming from constrained projections building on multiple lines of evidence to constrain climate sensitivity and its uncertainty range, we see that global warming will reach a level of 1.5 degrees Celsius based on the best estimate at the beginning of the next decade. This is a failure to keep the strongest aspiration of the Paris Agreement. And with current policies, a level of global warming of 2 degrees would be exceeded by the 2050s. Shifting track requires immediate, rapid, large-scale reductions in greenhouse gas emissions. Otherwise, limiting warming well below 2 degrees and as close as possible to 1.5 will be beyond reach. There are wrong ideas in the general public about how the climate system operates. Many people believe there's inertia in the climate system. Yes, there is. What has happened so far, the accumulation of heat in the ocean is irreversible. Losing about a third of the glaciers is irreversible, as well as long-lasting adjustment of the Greenland, the Antarctic ice sheets to current warming driven by emissions to date. But the current knowledge shows that if emissions would be at zero now, there would be no further warming. Future warming depends on future emissions. Looking at the various spread of scenarios, the very high emissions scenarios are now considered to be implausible in terms of the amount of use of fossil fuels and because of the current implemented policies that have already avoided several billions of tons of greenhouse gas emissions per year. So we need also our communities to work more closely to scrutinize the plausibility of the various scenarios, the biogeophysical constraints, water availability, cooling needs in a warming climate, and the equity dimensions of the various scenarios which are being challenged by our colleagues from the Global South when they look at the implications of the very low emissions scenarios for where they live. We need to better communicate to society, not just, the gradual projections, but what to prepare for, taking into account the modulation by natural variability, decade after decade. I was at the ENSO session this morning, and I'm struck by how little we know about the possible consequences of a large El Niño event in a warming world. So there are issues of understanding, for instance, El Niño by itself, but there are also actionable information that could be produced by thinking carefully of what are the consequences of different types of El Niño events, starting from a different background of ocean heat uptake that could be released to society for better preparation. When we look at the outcomes in terms of amber diagrams, these risks levels that go from moderate in yellow to extreme in dark purple, we see that both for the ocean and for the land, we are entering into risk zones for planetary health and degradation of ecosystems. We're still struggling about the land carbon feedbacks. What will be the implications of wildfire, permafrost degradation, mortality of trees, ecosystem disturbances and degradations for the ability of the land to absorb, as today, about a third of our emissions? Today's Earth system models suggest that above 2 degrees by around 2050, the ocean and land sinks would lose efficiency. However, they do not account for the complexity of all the biological processes at play, nor the local degradations that are happening with habitat destructions, pollutions, local pressures, which hamper the ability of ecosystems to absorb carbon. We need to better understand the implications of different amplitudes and levels of overshoot above 1.5 degrees Celsius, in particular for irreversible changes, not just on the near term, but on the very long term. And we must also better communicate to society what would be the benefits of sharper emission reductions, quickly improved air quality, quickly emerging signals for atmospheric composition, discernible effects of emission reductions on global warming levels within about 20 years. We need new knowledge to go beyond 2100 and to have robust information to support considerations of irreversibility and projection on timescales that are relevant for coastal city industrial developments that don't stop by 2100 as well. Our findings show really strongly how much every increment of warming matters. They matter for the frequency and intensity of extremes. They matter for the intensification of the water cycle and its variability, including very wet and very dry seasons and events, posing multiple challenges for water-related adaptation responses, a major source of tensions. Every increment of warming matters for irreversible sea level rise beyond 2050. And as you can see, the magnitude of sea level rise and its rate depend on two main things: future greenhouse gas emissions, but also the uncertain response from ice sheets and the deep uncertainty with possible ice sheet instability, represented in the middle panel with a dashed line, to give a sense of what goes beyond the most likely range of the knowledge that we have. We need to advance our understanding of abrupt behaviors at the regional scales and tipping points, so that society can be better prepared. We even don't have agreement in the cryosphere community on how to detect if an instability threshold has been passed, and we need these systems of early warning to be available. We need also to be able to bring together information on changing hazards, changing exposure and vulnerability, not just for the very long term, but as illustrated here by 2040, to illustrate where are people living in areas that will be exposed to the largest increased frequency of extreme sea levels within 20 years, given the long-term planning that is required to respond to both sea level rise, more frequent high tide flooding, higher and more frequent extreme sea level events, and coastal erosion. Finally, scientific knowledge also shows what is required to limit global warming. The first and dominant driver of future warming are cumulative CO2 emissions. So in this assessment cycle, we've managed to reduce the uncertainty on the estimates of the transient climate response to cumulative CO2 emissions, but the results are only represented until 2050 due to increasing uncertainties on the efficiency of the land and ocean carbon sinks in a warmer world. When we look at the remaining carbon budget, the one to limit warming to 1.5 degrees Celsius, updated to the latest data from this year, is already divided by 2. It corresponds to about 6 years at today's emissions rates. It means if emissions stagnate a couple more years, overshooting 1.5 degrees Celsius. When we look at the remaining carbon budget to limit warming close to 2 degrees, we see that if we consider the lifetime emissions from existing and planned fossil fuel power infrastructure, by itself, this sector would exhaust all the remaining carbon budget. The science is very clear. New investments in fossil fuels without capture and storage, which is currently absolutely not at scale, is not consistent with the Paris Agreement goals, and it has to be repeated and said everywhere and all the time. We also show that to limit warming, we have a gap between implemented policies and pledges, nationally determined contributions. It's really important to make sure that the pledges are implemented and affect real-world policy, but we also have this gap between the pledges and the trajectories that would be needed to limit warming well below 2 degrees and close to 1.5 degrees Celsius. We need to have also methods to update our knowledge, the scenarios, the modeling results, for instance, to be more reactive after surprises and shocks. It was done in a limited way to account for the effect of the pandemic on emissions, but still, so far, we don't have the tools to be able to take stock of the implications of conflicts such as the invasion of Ukraine to understand what would be the implications. Methane matters, and it matters because it can avoid a small amount of peak warming on the near term because it has a short lifetime, because it could also counterbalance the reductions of the cooling effect from pollution particles co-emitted with CO2, and because, as a main driver of surface ozone, reducing methane can help advance air quality benefits as well. At the moment, it is still striking that air pollution control strategies and climate mitigation strategies are not fully aligned, with more advances in reducing aerosol emissions that currently lead to larger imbalances, and therefore there's really a need for the scientific community to better inform comprehensive policy packages. So to finish this overview, I just focused on the parts of the physical science basis that were reflected in the IPCC synthesis report. It shows the importance of the advances in the physical science basis in an overall advancement of knowledge to empower transformations. A few thoughts on what we need. We need to target where uncertainty is the deepest. Aspects associated with what's happening now for the Antarctic sea ice, tipping points including ice sheet instability, the most difficult aspects related to the land carbon climate feedbacks. We need to advance our understanding of the interplay between climate change, ecosystems and biodiversity to support human well-being and ecosystem health at the same time. We need to advance basic understanding, in particular focused on clouds and atmospheric dynamics, which matters for both the global climate response and the profiles of regional hazards, in particular compound extreme or composite or synchronous extreme events that could challenge our abilities to manage risk with humanitarian responses. And one advance reflected in the AR6 report was to be able to constrain global climate and sea level projections, using the estimates of climate sensitivity to narrow the uncertainty range resulting from climate models. It is not fully satisfying, and at the moment we don't have methodologies available to deliver regional information consistent with the constrained global projections. We use global warming levels as an intermediate step, and it requires to advance the theoretical understanding, the assessment of the model fitness for purpose, to go beyond purely empirical approaches. In terms of actionable knowledge for society, I really think that, of course, we need to better relate to practitioners in regions, in sectors, to deliver the knowledge that is relevant for them, and advances in climate services help advance climate science in that direction. In terms of mitigation, in terms of adaptation, we need to better characterize the biogeophysical constraints in a warmer world at regional scales, in particular water availability and biomass availability, to avoid taking the wrong tracks in some of the response strategies that might increase risks through maladaptation or malmitigation. We need to have knowledge tools that can account for progress in climate action. Do you have the tools to assess climate impact, accounting for implemented adaptation responses, implemented mitigation responses? It is a new dimension of attribution, not just human influence on climate, but human influence on avoided risks. And it's extremely important to be able to measure that and provide that information to inform societies about what is effective adaptation, what is multiple benefit mitigation. I've already touched issues of knowledge gaps in some of the most vulnerable regions of the world. Ethics, power relationships, and equity are important considerations. There's a whole conversation taking place, for instance, on solar radiation modification. There are increasingly funding resources provided by philanthropists, billionaires, who fund that research, not something else, not advancing basic climate understanding, research on solar radiation modification. Why? What does it tell us on power relationships? What are the ethical dimensions of working in that direction as scientists? I think this is really critical to consider given the current situation. I've already mentioned the importance of evidence to support the loss and damage mechanism. It is currently missing, and attribution science is not mature already. Going back in 1990, at the start of the IPCC, there was not enough information on emissions. So there has been a huge work to develop methodologies to calculate and report emission inventories, and it plays a key role in our ability to track where emissions come from, how they are changing, how effective or not mitigation policies are. We need similar exercises as a community to monitor impact, understand the drivers of impact, human-caused climate change, impacts avoided by effective adaptation responses, and this is typically what is needed to support such a loss and damage mechanism. Finally, talking to young scientists, what do you find exciting? What would motivate you to join such an impressive collective intelligence effort as an IPCC report? We need to hear your voices so that you can inform the preparation of the next IPCC cycle starting the last week of July this year. The AR6 corresponds to 10,000 pages of reports. Who of you has read one summary for policymakers here? Who of you has read one whole chapter? One whole report? Good news, some companies have developed artificial intelligence tools where, in plain language, you can navigate within the 10,000 pages of IPCC reports. Bad news, they have not been designed for that. Typically, what we use is text, tables, and figures, and we don't replicate in text what tables and figures convey in terms of messages. So this type of conversational robots, when they only look at the text, they mix, in fact, much of the information which is conveyed and synthesized in tables and figures. So we need to make better use of these developments, artificial intelligence, to support, for instance, systematic literature reviews, to support the work of the authors, but also to inform the design of reports so that they can be actionable, they can be used with what people will use to look for information worldwide. It also calls for thinking very carefully of the next cycle as an opportunity to prepare more radical changes to how IPCC operates so that it can be implemented, probably in the early 2030s, in a 1.5 warmer world. And last point, we need IPCC to have new practices for inclusivity. I've touched about some of the issues, but also for sustainability. We need to show by example, as scientists. We are credible if we align what we know and how we operate, reducing our own climate footprint in a decent way, in a measurable way, effective way, is also part of being empowering transformations. To finish, this cycle has been a marathon. The next marathon is starting at the end of the month with new people bringing new momentum into that process. It's quite nice to receive a gold medal at the end of a marathon, but I cannot be satisfied. And I will only be satisfied as a climate scientist when I see action at scale to avoid risks for those most vulnerable. Thanks to the preparation of IPCC reports, I've been traveling in many continents. I've met people in highly vulnerable communities. I see them. I know what they are facing. And unless we take action at scale, no gold medal will be sufficient. Thank you.
So we have a few minutes left, and Valerie's very kindly agreed to answer questions. We're a little bit blinded here, so apologies if we miss raised hands. We'll try and look between the two of us. Maybe start here? Yeah.
Hello. Well, thank you very much for this enlightening, beautiful talk. I'm Jérôme Benveniste from the European Space Agency, and I would like to ask you a simple question. It takes 20 years to see some effect that would come out from policies and treaties. What kind of satellite mission, space mission would be needed in order to detect the effect in a couple years, 3 years, less than 5 years, which is the presidential mandate in most of the democratic countries, and be able to say that the efforts which are being done can be detected within 4 years? And I'm thinking of the water cycle. I'm thinking of the dramatic situation with floods and the opposite with drought. Well, drought, you can always add water if you can transport it, but floods sometimes is really the worst. And so what is the magic to be able to tell politicians within 4 years that what they're doing is good before they get reelected?
I don't have an answer just for remote measurements or satellite measurements. But clearly, at the moment, we still have a gap in the global observing system in terms, in particular, of aerosols and their effect on radiative forcing. So we need to have tools to be better able to real-time measure that, estimate the radiative forcing effect as one of the components at the interface between climate and air quality, which also affects, in fact, as a condensation nuclei, precipitation processes. And regarding extreme precipitation, everything that can advance early warning systems is critical to save lives. That's really the core part. So it's not just about the monitoring, and this is something really reflected in the IPCC reports. It's working so that the information is made available through adequate tools, reaching out to those most vulnerable. So thinking of those who live, for instance, in informal habitats, thinking of poor farmer communities, how can you ensure that with all the advances that we have in observational technologies, the information is reaching to them? And I think that's really the critical part. So it means having people coming from those communities being trained as scientists, being able to use that information and convey the right channels to reach out to these communities. So creating opportunities for science careers in our fields for people in those communities is quite critical.
Hi, Valerie. Great talk, presentation. I enjoyed that. It's Manu Cheshuzai from Virginia Tech. I have a comment on IPCC reports that you may want to address now or bring it to your colleagues. I think there is a very important component missing in the IPCC report, and that's a vertical land motion along the coast. So it's discussed a few places, but if you look at the list of the authors, there is not even a single expert from, land subsidence community. And we know for a fact that vertical land motion along the coast has a rate that is often faster than sea level rise. And if you want to reduce the uncertainty of the future projections, vertical land motion has to be treated more seriously. And again, when it comes to impact and risk, that's something that I think need to receive equivalent importance. And the driver of the vertical land motion, again, everybody knows that they're very similar to those drives, the sea level rise and rest of the climate change. So is there any plan for the future IPCC to address that? Thank you.
Thank you very much. And you're right, and there's a need to strengthen the approach to regional information with a specific emphasis on coastal ocean coastlines and local land movements. So it was partly reflected broadly in the Ocean Cryosphere report for the relevant chapter. But when you look at the Working Group 1, Working Group 2 reports, it's a bit hidden. There are elements, but they are not sufficiently well reflected. So if your community would be willing to provide specific recommendations, in particular on how to structure reports so that that knowledge can be embedded, reflected, and made more visible, it would be important. The Cities and Climate Change report could be an opportunity for that. And the start of the preparation of that report will probably be taking place in the coming months. So there's an opportunity, as a community, to reach out to the new IPCC Bureau and make sure that your own recommendations are heard and join, if possible, the scoping meeting as well.
Hello, thank you for the talk. My name is Colin Price from Tel Aviv University. I'd like to get your opinion on what our response should be to climate deniers. We see this dramatic increase in the last years, maybe related to COVID deniers as well, or vaccine, anti-vax people. And if you confront them, then you're giving them a stage. And if you don't confront them, they get the stage alone. So it's kind of a lose-lose situation. I'd be interested to see what you can suggest to us.
That's a really good question. In my view, the best option is to have a collective mechanism to do a fact check on disinformation that has been developed and is circulated, recirculated, so as to be able to provide really quickly and on the same network loops, the sort of correction that is available. I also think that one tool that we do not enough use is humor and sarcasm, because much of that material is, in fact, when you look in details, quite ridiculous. So having allies in the sort of, how to explain that, artistic community that can use the weapon of humor to show how ridiculous some of the counter-arguments are would help. And I think laughing helps opening minds as well. And finally, it's always interesting to look at the arguments and to understand how to address them, because whenever you do outreach, you will meet people who will try to reuse some of those arguments, sometimes of good faith. So it's always helpful as a scientist to know, what are the most frequent arguments and have quick ways to address them and show how completely disconnected they are from the actual state of knowledge. But many of you have probably different ideas, suggestions. I really think that we need to be more present as scientists on social networks. So myself, I'm more well at ease with words. I can use Twitter, and I never answer to a denier to avoid giving the person visibility. But I provide actual, solid scientific information to help good-willing people understand what we know. But there are other social networks using more like videos or images where that disinformation is spreading as well. And so we need also people well at ease with these social networks who can give a voice to science to counteract that.
We have one more question. If it's quick, we can take it, and then we must wrap up.
Sorry.
Please.
Okay. So thank you very much. You mentioned in passing the issue of assessing avoided losses. This is a big issue in disaster management as well. And my feeling is we don't have a way of doing it. We don't even have a mechanism that seems to be going in the direction of producing a generally agreed methodology for assessing avoided losses. Do you have any thoughts?
So we lack systems of monitoring impacts. I know that the World Meteorological Organization is working in that direction, at least to have like single numbers so that you can track one particular event, together with assessment of damages that often occur a bit later, delayed. And in terms of the scientific knowledge, it calls for advancing event attribution one step forward, which is not just the physical characteristics, but also the implications given the local responses that can exist and can reduce the risks or not as well. And there have been multiple papers. You just look at a couple of papers in Nature in the last months, really pointing to the exact directions where there are needs for advancing our knowledge, robust knowledge and methodologies, so that it could be available, not now, but maybe in a few years.
So I'm really sorry, but the clock has turned red here. So I'm going to wrap up just by very briefly thanking you, Valerie, once again for, it's just been a fantastic, broad, insightful lecture. Please, one more round of applause.